today's class. Just we'll briefly go through that, and meanwhile your friends will come and join, then we'll continue this class as it is. Okay, so these are the different embedded processor types. Before designing an embedded system, we have to select the processor, what type of processor I need, what type, maybe one or two processors you may need. You may have some microprocessors or microcontrollers, DSPs, ASICs, CPLDs, FPGAs, all this comes under different processors. So before designing any embedded system, we must choose which type of processor you need, which type of controller you need. Okay, these are the available processors or controllers to design an embedded system. Okay, and these are the memories, because memory is also one of the important part in an embedded system. So primary memory, secondary memory, ROM, RAM, sequential, random access memory. Okay, in the ROM, ROM we have a different, so masked ROM, programmable read-only memory, EEPROM, EEPROM, flash memory, static RAM, dynamic RAM, non-volatile RAM, under RAM. So in the sequential you have a olden days memories, magnetic tape, gramophone record. They are sequential, means they will start from the beginning and one by one it will go to the last time. So random access means you can access any file which is stored on the CD, DVD at your requirement. Okay, like that. Next, how this processor and memories are connected to the address and data bus. This is the architecture, how to connect your processor and memories. Okay, this is EEPROM, flash memory, RAM. Okay, these are connected to the address and data bus, and processor is connected to the address and data bus. So processor can communicate to these memory elements. Then we'll have a same thing, right? Whatever we have seen in the first slide, that is repeated here. And we have a code memory. Code memory means, I have explained you, code memory means this is the memory where all your program is stored. మనం ఒక ప్రోగ్రామ్ రాస్తాం కదండి, ఏదైనా ఫంక్షనాలిటీ, ఎంబెడెడ్ సిస్టమ్ ఫంక్షనాలిటీ. సపోజ్ ఇఫ్ యూ రైట్ ఎ ప్రోగ్రామ్ ఫర్ వాషింగ్ మిషన్ కంట్రోల్, that main program is stored in the code memory. Okay, flash memory, masked ROM, PROM, EEPROM, EEROM, NVROM, all these are the types of the code memory, or ROM, ROM. Okay, all these are the different types of ROMs. Okay, it comes under code memory. So code memory is stored in, so any one of these. Nowadays most popular one is so flash memory. Okay, flash memory is a very popular one in advanced embedded system where you can store the code. Now in the same way, RAMs, static RAM, dynamic RAM, non-volatile RAM. Okay, so this RAM read write memory, generally this is a memory used for the storing the variables temporarily. Suppose when you are doing some multiplication చేసేటప్పుడు మధ్యలో పార్షియల్ ప్రొడక్ట్స్ వస్తాయి కదండి. సో టు స్టోర్ దోస్ పార్షియల్ ప్రొడక్ట్స్ అంటే ఎగ్జాంపుల్, సపోజ్ ఇఫ్ యూ ఆర్ మల్టిప్లయింగ్ 20/10, ఫస్ట్ టైం చేస్తాం జనరల్గా 20 × 10 రాసి జీరోతో మల్టిప్లై చేసినప్పుడు ఆల్ జీరోస్ వస్తాయి, 1తో మల్టిప్లై చేసినప్పుడు 20 వస్తాయి. ఈ 0, 20 వీటిని ఏమంటామంటే పార్షియల్ ప్రొడక్ట్స్ అంటారు. ఫైనల్గా వాటిని యాడ్ చేయాలి కదండి, దట్ ఈస్ కాల్డ్ ఫైనల్ రిజల్ట్ అని. ఓకే, ఈ మధ్యలో వచ్చే ప్రొడక్ట్స్ని ఏమంటామంటే పార్షియల్ ప్రొడక్ట్స్ అంటాం. టు స్టోర్ సచ్ టైప్ ఆఫ్ ఇంటర్మీడియట్ రిజల్ట్ వీ నీడ్ సో ర్యాండమ్ యాక్సెస్ మెమరీ. ఓకే, దిస్ ఆల్సో వీ హ్యావ్ సీన్ యెస్టర్డేస్ క్లాస్. నౌ సో ఇవన్నీ ఎందుకు ఇట్లా ఆల్రెడీ మనం డిస్కస్ చేసినామండి ఇన్ యెస్టర్డేస్ క్లాస్. వీ హ్యావ్ డిస్కస్డ్ అబౌట్ ఆల్ దీస్ థింగ్స్ ఇన్ డీటెయిల్. నౌ జస్ట్ ఐ విల్ బ్రీఫ్లీ గోయింగ్ త్రూ దీస్ థింగ్స్. నౌ వీ హ్యావ్ ఏ సో డిజైన్ ప్రాసెస్ ఆఫ్ ఎంబెడెడ్ సిస్టమ్. ఒకవేళ మీరు ఎంబెడెడ్ సిస్టమ్ స్క్రాచ్ నుంచి అంటే బిగినింగ్ నుంచి డిజైన్ చేయాలని అంటే ఫస్ట్ స్టెప్ ఏంటంటే, ఇవన్నీ మీరు స్టెప్స్గా కూడా రాయొచ్చు, ఇట్ ఈస్ ఇన్ టర్మ్స్ ఆఫ్ ద బ్లాక్ డయాగ్రామ్. ఫస్ట్ వీ హ్యావ్ టు ఐడెంటిఫై ద రిక్వైర్మెంట్స్. అంటే మనం డిజైన్ చేసే ఎంబెడెడ్ సిస్టమ్కు ఏమేమి థింగ్స్ రిక్వైర్, అది ఏమేమి ఫంక్షనాలిటీస్ని చేయాలి. దట్స్ వాట్. సపోజ్ ఇఫ్ యూ టేక్ ఎ వాషింగ్ మిషన్ హ్యాస్ టు డూ మెనీ అప్లికేషన్స్ లైక్ it has to set the temperature of the container, so wheel rotation speed, and what type of cloth it has to wash. Like that there are different requirements will be there. So first of all we have to identify the requirements. Suppose if we are designing a water level indicator, so water level indicator లో మనకి రిక్వైర్మెంట్స్ ఏమేమి ఉన్నాయి అంటే ఎన్ని లెవెల్స్ మనం కంట్రోల్ చేయాలి, 3 లెవెల్స్ అంటే ఎంటీ లెవెల్ ఒకటి, మిడిల్ లెవెల్ ఒకటి, ఫుల్ లెవెల్ ఒకటి, అట్లనా లేకపోతే ఇంకా ఏమైనా అదర్ పారామీటర్స్ ఏమైనా మనం కంట్రోల్ చేయాల్సినవి ఉన్నవా రిక్వైర్మెంట్స్లో. సో ఆల్ ద థింగ్స్ బిఫోర్ డిజైనింగ్ వీ హ్యావ్ టు డిటర్మైన్ ద రిక్వైర్మెంట్స్. అంటే మనకి ఏమేమి డిజైన్ చేయాలనుకుంటున్నామో వాటిని అన్నిటిని లిస్ట్ అవుట్ చేయాలని ఫస్ట్. ఓకే, ఆఫ్టర్ డూయింగ్ దట్ డిజైన్ ద ఆర్కిటెక్చర్. ఓకే, architecture means, so what is the memory, what is the processor I want to use, what is the memory elements required, and what are data bus, address bus, how many interfacing devices are required. Okay, such a simple drawing designing the system architecture. Okay, once మనం రిక్వైర్మెంట్స్ని డిటర్మైన్ చేసిన తర్వాత ఆ రిక్వైర్మెంట్స్ని ఫుల్ఫిల్ చేయడానికి సిస్టమ్ ఆర్కిటెక్చర్ అండి, వీఆర్ గోయింగ్ ఫర్ సిస్టమ్ ఆర్కిటెక్చర్. సో after designing the system, in the system architecture we have to consider many issues like first what we have to do, what is the processor required, what are the memory elements required, and how many IO ports are required, like that. So before going to the further steps, so we have to first of all design the system architecture. అంటే ఇట్లా నా సిస్టమ్ ఇలా ఉండాలి, ఇన్పుట్ ఈ డివైసెస్ ఉంటాయి, అవుట్పుట్ ఈ డివైసెస్ ఉంటాయి, ప్రాసెసర్, మెమరీ, next other whatever the system is there. Suppose if you are designing some system, in that system how many things you want to control, like that. So that architecture must be designed. Okay, design the system architecture. Okay, architecture means you know that. Suppose see, if you take the example of building, in the building architecture means what? So you must have, suppose example, if you want to construct a house, suppose if you want to, you need 2 bedrooms and attached bathrooms, one hall, and a hall is connected to kitchen, like that. So different things, where at what location you need all these things, what is the size of each room, like that. If you are designing a house, so we have to consider different issues. Okay, like that. Where must be the kitchen, where is the hall, bedrooms, bathrooms, and portico, like this. So each and every part of the house must have a separate location. In the same way here also what we do is, so we have to design the system architecture. Here memory must be there, here controller must be present, so here output devices, like that. We have to identify the location of each part or each block of the embedded system. After doing that we have to select the OS. So OS selection means what type of OS is required for your embedded system. Suppose some simple applications require a very small OS, simple OS. Some mobile phone you need a very high complicated OS, like that. Okay, choosing the operating system. OS means operating system for your system, embedded system. Okay. After completing that, choose the processor and peripherals. Now what do you have to do? What type of processor I need? I go for 8051, or otherwise another 8086, 801862 Pentium, like that. ARM controller. What type of processor and peripherals? How many IO peripherals means input and output devices. What type of input device I need? Keypad or other some voice synthesizer, like that. What type of output means maybe output maybe LED display unit or LCD display unit, like that. So we have to choose the processor and peripherals. After choosing them, choose the development platform. So choose the development platform means, so development platform is nothing but where you write the code and execute the code and debug the code until you get the success of the code. అంటే మనం అనుకున్న అవుట్పుట్ వచ్చేంత వరకు ఎడిట్ చేసుకుంటూ ఫస్ట్ ఒక ప్రోగ్రామ్ కోడ్ రాస్తామండి, దాన్ని ఎగ్జిక్యూట్ చేస్తాం. మనకు అనుకున్న రిజల్ట్ వస్తే ఓకే, లేదు రాలేదు, సమ్ యూ హ్యావ్ సమ్ ఎర్రర్స్, దెన్ అగైన్ యూ ఎడిట్ ఇట్, డీబగ్ ఇట్, ఎడిట్ ఇట్, మళ్ళీ ఎడిట్ చేసి మళ్ళీ ఎగ్జిక్యూట్ చేస్తాం. అది ఎక్కడ వరకు అంటే ఇట్ ఈస్ అ సైకిల్ until you get the correct result. So then we will execute in the same way. Okay, so that is what is called. అయితే ఈ మనకి డిఫరెంట్ ఎన్విరాన్మెంట్స్ ఉంటాయి, ఐడిఈస్ అంటాం, ఇంటిగ్రేటెడ్ డెవలప్మెంట్ ఎన్విరాన్మెంట్స్. సో ఈ డిఫరెంట్ ఐడిఈస్ ఆర్ దేర్. సో వాట్ టైప్ ఆఫ్ ఐడిఈ యూ నీడ్, సో దట్ సెలెక్షన్ ఈజ్ ఇంపార్టెంట్. సమ్ ఐడిఈస్ ఆర్ వెరీ యూజర్ ఫ్రెండ్లీ, సమ్ ఐడిఈస్ ఆర్ దే ఆర్ నాట్ యూజర్ ఫ్రెండ్లీ. సపోజ్ యూ వాంట్ టు టైప్ ఏ కమాండ్, ఇట్ బికమ్స్ డిఫికల్ట్. అట్లా కాకుండా కమాండ్ కాకుండా ఒక ఐకాన్ ఉందనుకోండి, సపోజ్ మీరు ఫ్లిప్కార్ట్ ఓపెన్ చేయాలి. ఫ్లిప్కార్ట్ ఓపెన్ చేయాలంటే ఫ్లిప్కార్ట్ ఐకాన్ ఉంటుంది, దాని మీద క్లిక్ చేస్తే మీకు ఓపెన్ అవుతుంది. అలా కాకుండా ఏదో ఒక స్టేట్మెంట్ టైప్ చేసి ఎంటర్ లాగిన్ కావాలంటే ఇట్ బికమ్స్ డిఫికల్ట్ ఫర్ మోస్ట్ ఆఫ్ ద పీపుల్. మనం టైప్ చేసి ఇప్పుడు ఫ్లిప్కార్ట్ .com అట్లా అని టైప్ చేసి ఎంటర్ అయ్యేదానికంటే, సో ఇఫ్ యూ హ్యావ్ సమ్ ఐకాన్ ఆన్ ద మొబైల్ phone, just if you double click on that, immediately if you log into that particular website, then it becomes easy. It is most user friendly. Even uneducated people also can do that. So that must be there, right? So always the development environment, that whatever we are doing, so that development environment must be user friendly, and also it has to give the most comfort to the designer. After doing that, code the application and optimization. Okay, so what do you have to do? We have to write the program. Then after writing the program, ఫస్ట్ టైం రాసినప్పుడు ప్రోగ్రామ్ కరెక్ట్గా ఉంది, రిజల్ట్ కూడా కరెక్ట్గా వచ్చింది. అయితే ఇట్ ఈస్ ఆక్యుపైయింగ్ మోర్ మెమరీ, ఎక్కువ మెమరీ తీసుకుంటుంది అనుకోండి. కోడ్ ఎక్కువైనప్పుడు మెమరీ కూడా ఆటోమేటికల్లీ ఎక్కువ అవుతుంది. సో అలాంటప్పుడు దాన్ని ఆప్టిమైజ్ చేయాలి. ఆప్టిమైజ్ చేయడం అంటే నెంబర్ ఆఫ్ లైన్స్ ఇన్ ద కోడ్ ఈజ్ రెడ్యూస్డ్. యూ హ్యావ్ టు రెడ్యూస్ ద నెంబర్ ఆఫ్ కోడ్స్, నెంబర్ ఆఫ్ లైన్స్ మీన్స్ వాట్, కోడ్ సైజ్ ఈజ్ రెడ్యూస్డ్. దట్ ఈస్ వాట్ ఈస్ కాల్డ్ ఆప్టిమైజేషన్. కోడ్ సైజ్ రెడ్యూస్ అయితే అది మెమరీలో ఆక్యుపై చేసే ప్లేస్ కూడా తక్కువ ఉంటుంది. సో దెర్ ఫోర్ వీ హ్యావ్ టు ఆప్టిమైజ్ దిస్ that code. Once optimizing that code, verify the software on the host system. So this is important. But మనం ఒకసారి ఆప్టిమైజ్ చేసిన తర్వాత ఈ సాఫ్ట్వేర్ వర్క్ అవుతుందా లేదా అనేది హోస్ట్ సిస్టమ్ మీద మనం చెక్ చేయాల్సి ఉంటుంది, వెరిఫై చేయాల్సి ఉంటుంది. హోస్ట్ సిస్టమ్ అంటే ఎవరైతే డిజైన్ చేస్తారో, ఎక్కడైతే ఫస్ట్ నుంచి ఏ సిస్టమ్ ఏదైతే డిజైన్ చేస్తున్నారో, దట్ సిస్టమ్ ఈజ్ కాల్డ్ హోస్ట్ సిస్టమ్. హోస్ట్ సిస్టమ్ ఈజ్ ద వన్ వేర్ the program or application is developed from the scratch. Okay, that is what is called host system. And we have to verify that whether that application is working properly or not. After verifying that, then verify the software on the target system. This is the final step. Host system మీద పర్ఫెక్ట్గా వర్క్ చేస్తుంది, మనం అనుకున్న రిజల్ట్ అన్నీ కూడా వస్తున్నాయి, ఇంకా ప్రాబ్లం ఏం లేదనుకున్నప్పుడు టార్గెట్ మనం ఏదైతే ఫైనల్గా మైక్రో కంట్రోలర్ మీదకి ఎక్కడైతే మనం సెండ్ చేయాలనుకుంటామో, సపోజ్ మన మొబైల్ ఫోన్ ఉంది, మొబైల్ ఫోన్లో మనకి క్వాల్కమ్ ప్రాసెసర్స్ ప్రాసెసర్స్ యూజ్ చేస్తాం. క్వాల్కమ్ 720G ఇట్లా డిఫరెంట్ ప్రాసెసర్స్ ఉన్నాయి కదా. సో వన్స్ దానికి క్వాల్కమ్లో ఆ ప్రాసెసర్లోకి పంపించే ముందే వాళ్ళు హోస్ట్ సిస్టమ్ మీద వెరిఫై చేస్తారు. టార్గెట్ మీన్స్ హోస్ట్ సిస్టమ్ మీద ప్రోగ్రామ్ రాసి, సో దే విల్ ఐడెంటిఫై వెదర్ దట్ అప్లికేషన్ ఈజ్ వర్కింగ్ ఆర్ నాట్. దే విల్ వెరిఫై ఇట్. So after verifying that if everything is okay, then they will send that application onto the target processor or target system. Okay, these are the different so total 8 steps present in the design process of an embedded system. Okay, this is very important from exam point of view. Okay, in the examinations explain about the design process of an embedded system with need block diagram, then you have to do this. Okay, next you see the life cycle of the embedded system. Okay, this is also very important one. Okay, life cycle from exam point of view, this is a very very important one. So embedded design life cycle diagram. Okay, first different phases are there, total 7 phases. You see HW means hardware. Okay, hardware design path activities, software design path activities. Now you see phase 1, product specification. Okay, product specification means, so I want to design a system, embedded system. That system must have some 3 input ports, so 1 output port, and it must have some processor of this specification, and also it must have a RAM of 4 GB or 64 GB, like that. Okay, all these are called product specifications. Then phase 2, first మనం ఈ product specifications identify చేసిన తర్వాత, then phase 2, in the phase 2 we have to separate the hardware and software portions. Okay, so that is what is called phase 2, hardware software partition. So we have to, because see some functions are see designing means a processor selection and IO port selection, means output devices, input devices, all these comes under hardware, and that is called hardware partition. And software partition means we have to what type of programming language you need to design, what type of IDE, and what type of debugger, and all these comes under software partition. So therefore we have to partition the software and hardware. After doing that, phase 3, iteration and implementation. Here what we will do is so we will continuously check for implementation. Iteration means, so we will suppose if we do one step, then we go to the second one, third one, then I come to the first one, whether it is working properly or not, right? That is called iteration in the same operations continuously. And implementation of this hardware and software partition. So the phase 3 is it is actually the starting of the designing of an embedded system. Okay, now in the fourth phase, detailed hardware and software design we have to do. Detailed hardware and software design means what are the hardware components I need and what are the software components I need, how to means what block must be located where. Suppose see I have a random access memory block, so this block has to be kept where it has to be kept. In the same way, ROM and digital signal processors, microcontrollers, so where to keep all these hardware components. Okay, that is what is called. In the same way, software design. Now we have phase 5, hardware software integration. Now because already I told you embedded system is nothing but it is a combination of both software and hardware. Okay, hardware only cannot do anything, software only cannot do anything. When both these two things are integrated, then it will work as an embedded system. Okay, because see if you take the AC machine, AC mechanical compressor will be there, cabinet will be there, sensors will be there, actuators are there, all these are the hardware components. But inside that you have a microcontroller. Inside that microcontroller we have a program. Whenever you type some changing the temperature on the remote control, automatically the AC machine can understand what temperature you are asking to set. How it knows? All that is known by sensors, and internally you will have a program to set the temperature. That is actually what is called hardware and software integration. Hardware and software integration means, so integrating the hardware components as well as software components into a single system in order to achieve a specific task. Okay, that is what is called integration. Hardware and software integration, combining the hardware, because hardware things are designed separately, software things are designed separately, and they are combined into get one application. Okay, that is what is. So phase 5. Phase 6 is acceptance testing. Okay, this acceptance testing is nothing but generally once after designing the system, we will test it whether that system is working according to your requirements or not. Okay, if it is okay, then we accept it. Otherwise, again we go here. We'll go here, then we'll debug the program, then we'll implement again, then simulate, then execute, do all the things. Okay, then accept. So phase 6 will be, it is a repeated step. You can do the testing differently for different applications. So once if you satisfy, if you accept up to that point, so it will be so cyclically executed. Then finally maintenance and upgradation. Okay, this is actually okay, we have designed the system. మనం ఇప్పుడు సపోజ్ ఏసీ మిషన్ కొన్నాం అనుకోండి, everything is working properly, so they will come and install in our house. After some time, generally they will come and maintain your machine, whether it is working properly. They will have a 3 maintenance checks. Okay, suppose if there is any upgradation for your device, so they will come and upgrade the system. Okay, like your in the mobile phone, whenever there is an upgradation, OS patch will be there, automatically you can download and you can install it again. So like that, maintenance and upgradation are the two important steps at the customer side. Okay, now going to the next one. Okay, these are the things whatever we adjust. After each visit end, the team meets offsite for a debriefing, like this. So now that's what I am doing here. See, partitioning the design into software and hardware components. Since the embedded system will involve both hardware and software components, someone must decide which partition of the problem will be portion of the problem will be solved in the hardware and which is in the software. Okay, so this is what we have discussed already, all these things. So now iteration. In this stage, hardware and software specifications are divided into individual modules and design them. So update the design repeatedly until we get the desired response. Okay, already just now I told you, see, whenever you design a system, you test that system. Okay, after testing, if you are not satisfying with that result, then suppose if you design a car cruise brake control system, so we need a response time of 1 millisecond. అంటే మనం బ్రేక్స్ అప్లై చేయగానే 1 millisecond బ్రేక్స్ అప్లై కావాలి. అలా కాకుండా 1 minute తర్వాత బ్రేక్ అప్లై అవుతుంది అనుకోండి, దెన్ వీఆర్ నాట్ సాటిస్ఫైడ్ విత్ దట్ response time. We have to increase the, means we have to reduce the response time. So therefore we must have a very less time between applying the brakes, means pressing the brake and applying the brakes, like that. So therefore until you get the proper result, we have to repeat it, we have to recode it, we have to optimize the code until you get the correct response time. Example of a car braking system, so we have to revisit it and recode it, then execute it, then finally identify whether it is working properly or not. Okay, so this is what we have seen: integration of the hardware and software components, product testing and release. Okay, each embedded system has its own proprietary tools for design, integrate, debug and testing. Example, these are the different examples of the Kano frame generator testing tools are used in automotive embedded networking. Okay, IDE means integrated development environment tools. Code, CCS means code composer studio, Keel software. All these are the Keel, CCS, IDE, these are the different CCS, Keel are the different IDE tools. Keel software is most popularly used for 8051 microcontroller. CCS is for digital signal processors. Okay, like that we have a different IDE tools are there to design the different domains. Okay, Keel software or Keel IDE is used to design on the 8051 microcontroller. CCS, code composer studio, is used to design this IDE is used to design the DSP applications. Okay, so this maintenance, see, the majority of the embedded system designers maintain and upgrade existing products rather than design new products to reduce the development time and release the right embedded system into the right time. Okay, so this ongoing maintenance is a very very important one. Once if we design a system, if the system is working, example if it is working for 15 to 20 years, so maintenance is very important and upgradation is also important. Suppose if some new feature comes, people will try to purchase that, because however finally designing an embedded system means finally we have to market it, we have to sell it into the market. So if the product is good and features are more and price is cheap, price is less, then more people will afford, more people will purchase it, and so therefore the designer or otherwise owner will get profits. Okay, that is a final aim of any system design. Next, so this is programming languages and tools for embedded system design. Okay, so embedded code is generally written before 1980, 1990. Before that, assembly language is used. Only assembly language. Assembly language ante meeru 8086 lo chadukuntaru kada, mnemonics, mu a comma b, add b, like this, call, return, jump. So those means that programming, that instructions forms a assembly programming language. That is somewhat difficult. We have to remember the mnemonics and but it is somewhat fast. ఎందుకంటే అసెంబ్లీ లాంగ్వేజ్లో మనం ప్రోగ్రామ్ రాసినప్పుడు డైరెక్ట్గా అసెంబ్లీ లాంగ్వేజ్ నుంచి మిషన్ లాంగ్వేజ్లో కన్వర్ట్ అయిపోతుంది. దట్ ఈస్ ఫాస్ట్ ఎగ్జిక్యూషన్. దిస్ ఈజ్ ఎ వెరీ ఓల్డ్ మెథడ్ ఆఫ్ రైటింగ్. టుడే ఆల్సో if you want a fast execution, especially in embedded design, this assembly language is very popular one. Okay, especially in some domain. But C and C or C++, these are two languages, C, C++, embedded C ani unnadi. Okay, these are the different variations of C programming. these programmings are also used to use ఇంతకుముందు యూజ్ చేసేవాళ్ళు వీటిని in 2000 2002 2003 up to that time this C and C++ are very popular. Java script, ada script, ada, all these are the ADA, all these are the different programming languages useful to design an embedded application. This Python is a very advanced one. Python programming language or Python programming is a very popular nowadays in almost all. So embedded, not only embedded, you take any type of course, data science, networking, you take any new application development. So this Python is a very popular programming language because the main reason is, so in the Python programming we can write, so 100 lines of C programming can be implemented in just 6 or 7 lines of Python. That is the main important part of the Python programming language. Okay. So programming tools. A programming tool or software development tool is a program that software developers use to create, debug, maintain, support other programs and applications. Okay, what is the meaning of this? So program tools means it is a programming from somebody. I am getting a noise, please mute yourself. Mute yourself. Hello, I am getting some background noise from somebody, please mute yourself. Okay. Okay, so programming tools means the programming tools which are used to design the programming, to write the programming. You see this, create the programming, debug the, after create means what, writing the programming, after writing the program, debug, maintenance. Debugger different software, editor is different, maintenance is another one, support is another. Like this we will have a different programming tools. Then so in this programming languages and tools for embedded design. Now so in the programming tools we will have a this many number of subsystems or otherwise sub modules. Okay, we will have a compiler. What is the purpose of compiler? Compiler compiles the program. It will convert high level program means like C, C++, Java, that programming into so assembly level programming. Okay, and final ga mission understandable language loki ravalandi, ante zeros and ones. Okay, that is called mission language. Now this compiler, what it will do, it will convert so high level programming to assembly programming. Then we have a assembler will convert, assembler or interpreter, it will convert assembly programming into mission programming or otherwise zeros and binary executables. Then linker, locator, loader. Linker means what it will do is it will link the different copies, different parts of the program, because we have a headers, then main memory, and we have a RAM, heap, stack, different memories will be there. So it will locate it, and after doing that it will load. Loader, what is a loader? Loader is a program, it loads your written code onto the RAM. Then debugger, what it will do? Debugger means it is a software program which is used to identify the errors in your program. It is a software utility. It is a software utility, a simple software application. By using this debugger, we can verify line by line. Suppose my program lo 100 lines, 1000 lines, 5 lines unte normal ga direct ga check cheyachandi. Suppose in your application, embedded application, you write some 1000 lines of code. In the 1000 lines of code, manually checking is very difficult. So that is why debuggers are useful to identify the error and verify the error, correct the errors. Okay, that is the purpose of the debugger. Now we'll have a compiler, right? So everything, see, compiler, already I told you, a compiler is a computer software that transforms computer code. Computer code means like generally writing the program in C, C++, Java, like that, written in one programming language into the another programming language. Okay, so now what this compiler will do? Compiler will convert source code to object file. Okay, source code to object file. That is this one you have to remember. compiler will convert a source code. Source code means a code written in C, C++, Java, like that. Okay. Now object file means what? It will have opcodes. Opcodes means like your mnemonics, assembly programming. Then assembler, interpreter. So then what is this assembler do? An assembler is a software program that converts source code of assembly language into machine language. Okay, that's all right. Already I told you. So compiler will convert high level programming into assembly programming. That is important point you have to remember. Compiler, what is the job of the compiler? First it will take the high level programming like C, C++, then it converts into the assembly language which will have some mnemonics. Okay, then after after compiler, that compiled program is sent to the assembler. What assembler will do is, assembler identifies the assembly language programming, it converts it into the machine programming. That is important. Next, linker. A linker is a program that takes one or more objects generated by compiler and assembles them into a single executable program. So ఈ assembler ఏం చేస్తుంది? Then generally once if you compile, then after compiling you have a assembler, then what? So you will have a one or more objects generated by compilers and assemblers. Then all these objects are related to a single program. Now this linker will take all that separate files and it will combine into a single executable file. That is the job of the linker. Now we have a locator. A locator is a tool that performs the conversion from relocatable program into executable binary image. Okay, this is the purpose of the linker. A locator is a tool that performs the conversion from a relocatable program to executable binary image. So then what this locator will do? So see this. The locator assigns physical memory address to code and data sections within relocatable program. Okay. First it will, before locator what we have a linker. So linker will create a single object file. Then that object file is given to the locator. Locator will, what it will do is, it will relocate that entire object file into a different memory locations like program memory and data memory. So that the locator assigns physical memory address to the code and data instructions. Code means what? Program. Suppose the move a comma b and move is the program, a comma b is the data. Move a comma b. Okay, the contents of b is moved to a, then the move a comma b ante. So move mov means it is a program, a comma b are the data. So therefore this locator what it will do is, available physical memory is given to some program and some data, right? So suppose if you have a data, some memory available for you, what this linker will do is, this linker relocate your complete one executable file into that memory, into a program memory and data memory. Already program memory, data memory separate ga untundi. So what this locator will do is, so to store that program instructions, locator locates the physical memory, and also to store the data variables, so locator assigns the physical memory from the system memory. Okay, so therefore locator, what is the purpose of the locator? Locator assigns a physical memory address to code and data sections within the relocatable program. The locator produces a binary memory image that can be loaded into the target ROM. Okay, clear? Are you clear, all of you? So locator is a very important one. What it will do? Locator is a tool that performs conversion from relocatable program to executable binary image. Okay, so what it will do? It will take that single memory. Actually, it is a single file in the linker. What linker will do? Linker means a linker combines all the subsections of the program. It will have a one single footprint. Then locator will assign a physical memory address to the code memory and program and data memory. Code means a program memory. Okay, so physical memory will be there. So some part of the physical memory is allocated to the program and some part of the physical memory is allocated to the data. Okay, example just move a comma b means mov is the program ఆ mov ఎక్కడ స్టోర్ అవుతుందంటే ప్రోగ్రామ్ మెమరీలో స్టోర్ అవుతుంది. ఏ కామా బి అనేది ఎక్కడ స్టోర్ అవుతుంది, సో డేటా మెమరీలో. అది ఎవరు చేస్తారంటే లింకర్, రైట్. నౌ లోడర్ అండి. సో నౌ ద లోడర్ ఈజ్ అ పార్ట్ ఆఫ్ ద ఆపరేటింగ్ సిస్టమ్ that is responsible for loading the programs and libraries, because see, in embedded systems we'll use some math library and also we'll IO library. Different libraries are predefined, libraries are available, we use them. We need not to write all the library files again in the program. Just if we include that files, they are available for you to design an embedded system. So therefore what it will do is it is responsible for loading the programs and libraries. Okay, so that is the purpose of the loader. It is one of the essential stages in the process of starting a program, as it places programs into memory and prepares them for execution. Okay, ఏం చేస్తుందంటే ఈ లోడర్ ఏం చేస్తుంది, now the program is available in the memory. Now loader, it takes that program and it loads into the RAM, random access memory, so that it will be executed. Okay, loading a program involves reading the contents of the executable file containing the program instructions into memory and then carrying out other required preparatory tasks to prepare the executable for running. Okay, so this is the purpose of the loader. Okay, simply loader means, so actually a physical programming file is available on the memory. Whenever if you want to execute that memory, loader takes that program from the physical memory, then what it will do is it loads into the random access memory, that is the executable memory. Okay, so then it will store that, it loads that executable file onto the memory, a temporary memory we can say that, so that it will be executed. Okay, it is a part of an operating system that is responsible for loading the programs and libraries. Simple statement. మీరు లోడర్ గురించి రాయాలనుకుంటే లోడర్ ఈజ్ ఏ పార్ట్ ఆఫ్ ఆపరేటింగ్ సిస్టమ్ దట్ ఈస్ రెస్పాన్సిబుల్ ఫర్ లోడింగ్ అండ్ ఎగ్జిక్యూటింగ్ ద ప్రోగ్రామ్స్ అండ్ లైబ్రరీస్. నెక్స్ట్ వన్, debugger. Okay, so a debugger or debugging tool is a computer program that is used to test and debug other programs or target, that is called target program. Okay, so now after this, that's all right. Okay, so that is the end of the first unit. So here whatever we have seen up to this, okay, this one, from here programming languages and tools for embedded design: compiler, assembler, interpreter, linker, locator, debugger, loader, like this. So these are important from exam point of view, because so in the exams I will share you the questions also, notes also, after the most probably today or Monday I will share with you. This is a very important part. Sometimes you will get in the examinations, explain about how to design an embedded system software. Okay, coming to the software, this is an important part. So whenever you write a program, after writing the program you have to compile it, and after compiling then you will get some assembly programming, then using assembler you can have a machine programming, then linker, locator, loader, debugger. So loader is a very important one. It loads your program onto the executable memory. Okay, so it is loader is responsible for executing your program finally on the C. So it is a part of an operating system that is responsible for loading the programs and libraries. Okay, so programs means it is an executable file. Program is not a pure C programming or otherwise any assembly. Already that program is, even if you write a high level programming or middle level programming like C, C++, that is converted into first assembly, then assembly to machine, and once if it is converted into machine programming, then we will have a different separate sub files. So linker, what it will do, it links all the sub modules into a single module, a single footprint. Once the single footprint is available, then locator will do. Then locator, already just now I told you, locator is a tool that performs conversion from relocatable executable binary image. Okay, this locator assigns a physical memory for your code and data, and after that loader. So once memory ganaka ready aithe program ku plus data ku, then loading program instructions into the program memory, data into the data memory, that is what is called loading. Okay, so that's all. That is the end of this session, and also unit. First unit is completed. Now most probably by today evening or tomorrow I will share you that material and previous question papers corresponding to this unit in the your WhatsApp group. Okay, I will send you. Thank you. If you have any questions, you can ask me. Anybody of you have any questions, you can ask me here. If you don't have any questions, now you can wait for 1 minute. I will take the attendance. Okay, if you don't have any questions, you can leave the session.